Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to name acids. So this is called acid nomenclature. Nomenclature is the naming of things. So we're going to talk about how to name acids in this video. So the first thing is that we have two groups or two categories of acids. One is called your binary acids, and one is called your oxyacids. And the names kind of tell you about the acids. So binary acids are acids that contain two elements, right? So the first element is hydrogen, and your second element is some highly electronegative element. And so that's what binary means. It means like two. So when you have a binary acid, you're going to have two elements. And like all acids have a hydrogen that is going to come off. And H plus, they're going to produce H plus ions. And so they're going to have a hydrogen that's going to be able to ionize off and become your H plus ion in solution, or your hydronium ion in solution. And so, of course, in a binary acid, one of your elements has to be hydrogen, and the other one is some other element, usually a very highly electronegative element on the periodic table. And so let's go through the steps of how to name binary acids. So step one, you're going to begin with the word hydro. So when you're naming a binary acid, all of those acids are going to begin with the word or the prefix hydro. And you can remember that by thinking like hydro means hydrogen. That's one of the um, elements in your acid, in your binary acid. So the name should kind of identify what is in the formula. So you begin with hydro to identify hydrogen as being part of the formula of your acid. And so normally hydrogen acids are written with the formula beginning with hydrogen. So you begin with hydro for hydrogen, then you add the root of the other element. So basically what you're going to do is just add to that the name of your second element and drop the ending, right? So if your ending here, let's say your second element is bromine, then you would add the word bromine to hydro, so it'd be hydrobromine, and then drop the ending, ine. Drop the ine ending, and then you have hydrobrom, so that's your root. And then second, you're going to add ic, IC at the end of the root. So brom, yeah, is the root of bromine, and then you add ic, so it becomes bromic. And then you just add the word acid. Okay, so follow those steps, and when you're naming the binary acids. So, for example, here I have three examples. I was kind of just going over this one just a moment ago. So HBr, that's that's a, a binary acid. It's got hydrogen and bromine, a highly electronegative element. Um, Also, to just go back here to the second group is called oxyacids. Those are the acids that have oxygen in them. So none of these have oxygen in them, so they've got to be binary acids. Plus, they've got two elements, so that fits the name binary. So for this one, we have HBr. So the first thing is to write hydro for hydrogen. So we have hydro, and then bromine here is our second element, so we're going to add that, but we're going to drop the ending, the ine ending, and we're going to have just brom. And then we add the IC ending to the end of brom, so it becomes bromic. And then finally, we add the word acid. So two words. So hydrobromic acid. So HBr is hydrobromic acid. We could do the same thing with HCl. So HCl, a binary acid, no oxygen. So we start with hydro again. So hydro for hydrogen. Now this time the element is chlorine. So we're going to add the word chlorine and drop the ine ending. So that's chlor. And then you add IC to the end of chlor, and then add the word acid. So hydrochloric acid. And then finally we have HI. So again, it's a binary acid, no oxygen. So we're going to begin with hydro. So hydro for hydrogen. Then we add the root of the other element. Our other element is iodine. So drop the INE ending. So it's going to be iode. So instead of iodine, it's iode, dropping the INE ending. And then you add ic at the end of it, IC. And then the word acid. So this is hydroiodic acid. And that's how you do it. So you would do that with every binary acid, hydro, and then the root of the second element, followed by IC, and then add the word acid. Okay. What about oxyacids? So these are going to be the acids that have oxygen in them. And these are going to be the acids that are made up of some polyatomic ion, right? So you have sulfate ions, you have sulfite ions, you have nitrate ions, nitrite, or you have other polyatomic ions as well that have oxygen in them. So you can think of these acids as being polyatomic ions that have oxygen in them with H plus added to the ions. So the way you're going to name those is you start with the name of the polyatomic ion, right? And then you're going to drop the ending and add IC, or you're going to add OUS. And so depending on what the ending of your polyatomic ion is, that's going to determine whether you add the ic or the us at the end of the polyatomic ion name. So here, if you drop an ATE ending, so if the polyatomic ion has an ATE ending and you're going to drop that, you're going to add ic. So any polyatomic ion that has an 8 at the end of it, you're going to drop it and add IC. If you have a polyatomic ion that has ite at the end of it, then you're going to drop that ending and you're going to add OUS, us. After that, you're going to add the word acid. Now notice here, what's different here is you don't start with hydro. Hydro is only for your binary acids. For your oxyacids, you don't have hydro. You don't begin the name with hydro. So that's a major difference between these two. So don't confuse these two methods of naming. So don't use hydro for your oxyacids. So let's go over a couple of examples. So what I'll do is I'll go over some examples. I'll kind of review naming of the polyatomic ions, and we'll go from there. So stay with me. Okay, so let me go over and review how to name your polyatomic ions, specifically when you have four that look very similar, and the only difference is the number of oxygens. So this also works with two. So I'll talk about like what if you have two ions, polyatomic ions that only differ in the number of oxygens. So first, with regard to four, right? When you have, let me go ahead and use an example here. So we could do PO3, 3 minus, and PO4, 3 minus. And so here you can see, okay, I have two polyatomic ions. They both have P and O, phosphorus and oxygen, but they differ by one oxygen. So you name them by taking the one with the more oxygens and giving that an AT ending. So you take phosphorus, drop the ending, right? And then you add the 8 at the end of it. So we have 4 oxygens here. So this one, the one with more oxygens has an ATE ending. The one with less oxygens has the ITE ending. So this one would be phosphate, and this one is going to be phosphite. And that's how you name your polyatomic ions, and that's how you figure out, okay, which one's going to have the ATE ending and which one's going to have the ITE ending. And so that is kind of a review on how to name your polyatomic ions if you have 2 ions that just differ in the number of oxygens. Now, what about if you have 4? So here I have 4 polyatomic ions. They all differ in the number of oxygens. How do I go about naming these? Well, you should always start with the middle 2, right? So the middle 2, you're going to name exactly like as if you only had 2 of them, right? So just as I here looked at these 2 and said, oh, this one has more oxygens than this one, then this one's going to have the ATE ending, and this one's going to have the ITE ending. So I do that with the 2 middle ones. So here I have these 2 middle ones, 2 and 3. Which one has more oxygens? This one. So this one is going to be chlorate, right? So I drop chlorine. So the element name chlorine, drop the ending, and I add ATE for chlorate. Just like here, phosphorus, I drop the ending, and I get phos, right? And then I add ATE ending. So here it's going to be chlor plus ATE. And then that this is going to be my chlorate ion. And then my ClO2, which has 1 less, is going to be my chlorite ion. So it has 8 and ite. So you begin with the 2 middle ones, you name them just like you normally would with your 2 polyatomic ions. And then what about these 2 here? Well, for those 2, we're going to have to add some prefixes. So here, this one has 1 more oxygen than chlorate. So we're going to keep the 8 ending. That doesn't change, right? But what we're going to do is we're going to put a prefix in front of it, per. So here, we're going to start with per for our prefix, and then we'll add chlorate. Oops, let me fix that. Chlorate. So this is your perchlorate ion. And then this one, now this one here, it has 1 less oxygen than chlorite. So we're going to keep the chlorite and add a prefix to that one. It's going to be a different prefix. So instead of chlorite, it's going to be hypochlorite ion. So this one has the AT ending, but we added per to it. So per is going to be the prefix you're going to add if you have 1 more oxygen than chlorate. And then for this one, if you have 1 less oxygen than chlorite, you keep the ite ending, and then you add the hypo to the beginning of it. And that's how you would name any set of polyatomic ions that you have of 4. First name the middle 2. The one with more oxygens has 8. The one with less oxygens has ite. And then if you have the other 2, the one that has more oxygens than your chlorate or your 8 ion is going to have a per in front of it. And the one that has less oxygens than your ite is going to have a hypo in front of it. And that's how you name your polyatomic ions when you have different numbers of oxygens. Okay, so that's a good review of your naming the polyatomic ions. So what about your acids? So we go back to the steps of naming your oxyacids. So again, whatever the name of the polyatomic ion is, you're going to take that name first, right? So if I take this one, hypochlorite, I'm going to take the name, right? Let's write the formula for it. So let's see here. So I'm going to take, if I have my acid, let's say my acid is HClO. HClO is the acid. Notice that it begins with hydrogen. So it's an acid. And notice that the rest of it is a polyatomic ion, ClO, right? So in this case, I'm going to then name this acid by its polyatomic ion. So here its polyatomic ion is ClO, so that's going to be hypochlorite. So I start with that name, hypochlorite. And then I'm going to drop the ITE ending. And since this has an ITE ending, I'm going to replace it with OUS ending. So I'm going to replace this with OUS. And then the final step is you just add the word acid. Hypochlorous acid. So this acid, HClO, is hypochlorous acid. What if I have, again, HClO2? So HClO2, again, an acid, it's an oxyacid because it's got this oxygen in it, and ClO2 is a polyatomic ion. This is your chlorite ion. So again, I follow the steps. I take the name of the polyatomic ion. In this case, I'll write it here. So the name of the ion is, chlorite. ClO2 is chlorite. I'm going to drop the IT ending and replace that with OUS. So anytime your polyatomic ion ends with ITE, drop it, add OUS. So I'm going to drop this, add OUS, and then add the word acid. So this one is called chlorous acid. So this acid is called hypochlorous acid. This acid is called chlorous acid. What about ClO3? So here I have HClO3. So notice it's beginning with H, so this is an indication that this is acid. All acids begin with H. So I have an acid, ClO3 is the polyatomic ion with oxygen. So that name is chlorate. So I'm going to start with chlorate. Then since this ends in ATE, I'm going to drop the ATE and add IC, IC. So you drop the ATE ending, add IC, and then add the word acid. So this is chloric acid. And then finally, ClO4, if I have HClO4 for my acid, again, I'm going to take the ClO4 part of it. I recognize, oh, that's my perchlorate ion. So I'm going to start with that. So I have perchlorate. It ends in ATE. I'm going to drop the ATE and add IC. And then add the word acid. So perchloric acid. So I have hypochlorous acid, I have chlorous acid, chloric acid, and perchloric acid. And that's how you go about naming your oxyacids. Okay. Um, so some of these are going to have weirder names, and there's a few things I want to go over a little bit, and I'll go over that next. So hold on tight. Okay, so continuing with oxyacids. So there's some names in oxyacids that are kind of a little off, and that makes them sound better. So for example, if you have H3PO4, this is an acid. Notice that we have the polyatomic ion phosphate. Normally what you would do is just drop the AT ending, so you get phos, right? So you drop phosp, and you have the AT ending, and then you drop that phosp, and then you add IC, and you get phosphic acid, but we don't name it phosphic acid, we name it phosphoric acid. So it just sounds better. Um, so don't name this phosphic acid, it's actually phosphoric acid. So it's one of those things you kind of got to name, or you got to remember how to name it. Again, H3PO3, so phosphite. So here we have phosphite ion. It's an acid, it's an oxyacid. So again, normally you would drop the IT ending at OUS, so it would be phosphorus acid, but we don't name it phosphorus acid, it's actually phosphorus acid. So you have the OR there. So again, it's one of those things you just got to remember. Another one is H2SO4. SO4 2 minus ion is sulfate. So in this case, you would, okay, well, I'm going to drop the AT ending. So sulfate, drop the ending, you get sulf, right? And then you add IC, and so it'd be sulfic acid, right? That's what you would expect based on what we just went over regarding the naming. But we don't name this sulfic acid, we name it sulfuric acid. So we just keep the name sulfur and then add IC at the end of it. So some of these names are going to be a little off, and you just got to remember those differences and just memorize those names. When you're writing formulas, make the formula neutral. So kind of remember this as kind of an ionic substance. Acids are not ionic substances. They are molecular substances, but they ionize in water. So they kind of behave like ionic substances, but they're not ionic. But you can name them or write the formula by balancing charges, right? So if I have a polyatomic ion here, for example, CO3 2 minus, that's my carbonate ion. So my carbonate ion is has a 2 minus charge. So to write the formula for the acid of this carbonate ion, I would balance the charge by adding 2 H pluses to my CO3 2 minus. So I need 2 H pluses to balance the negative charge on my carbonate. And so when I write the formula, I have 2 hydrogens in the formula with my carbonate ion, so H2CO3. So for my phosphate ion, it has a 3 negative charge, so I'm going to need 3 H pluses to balance that, and so I have H3PO4. So the number of hydrogens you need is determined by the charge, the negative charge on your polyatomic ion. So you need enough hydrogens to balance that charge. So that's how you know how many hydrogens you need in the formula. Okay, so keep track of that. And also here, again, we have carbonate here, drop the ATE ending, add IC, so it becomes carbonic acid. Oh, yeah, and then finally, the names get weird pretty quickly. So some names are weirder than others. And so what I would do is just focus on the patterns that I've went over already. And just get used to the weird ones. Those are ones you're just going to have to remember how to name them and how to spell them, because the spelling's not going to be as what you expected, just like with phosphoric acid, not phosphic, and sulfuric acid, not sulfic. So, oops. Sorry again. So yeah, you're just gonna have to deal with those a little bit. All right. So lastly, let's go over some examples. All right. Sorry about that. So here are 5 examples. What I want you to do is just pause the video, try to answer these, and then start the video, and you'll see if you're right. Okay, so we start with HF. HF, you should identify right away as a binary acid. There's no oxygen, and it's made up of 2 elements. So this one would be starting with hydro. So it would be hydrofluoric acid. So that's HF, hydrofluoric acid. The next one is an oxy acid. It has oxygen in it, so we're going to identify NO2 as the polyatomic ion. So NO2 minus 1, we know there's a -1 because it's got 1 hydrogen, so that's going to be a negative. So NO2 negative is your nitrite ion. So we're going to start with nitrite and drop the IT ending. So we're going to drop that. So nitrite, drop the ending. And since this is IT, it's going to be OUS ending. And then add the word acid. So nitrous acid. Okay, what about number 3? Number 3, HNO3. So again, an oxy acid because we have oxygen. And so we're going to look at the NO3 part and ignore the hydrogen. So NO3 is our polyatomic ion. It's got a -1 because we have 1 hydrogen. So NO3 minus is nitrate. So no hydro because that's only for our binary acids. So we're going to start with the name nitrate. We're going to drop the ATE ending and add IC. So it's going to be nitric. And then add the word acid. So nitric acid. Number 4, H2S. H2S, binary acid, no oxygen, and it's got 2 elements, 1 hydrogen and 1 sulfur. So we're going to use hydro. So we're going to begin with hydro for hydrogen. And then the sulfur here, we're going to write, and then this is one of those weird ones, it's going to be sulfur. So not sulfic, but sulfur, and then you add the IC. So this is one of those weird ones you got to remember. So this is hydrosulfuric acid. And so that's the name of this one. And then finally we have here, so this is a polyatomic ion. This is an oxy acid. So what's the charge on the polyatomic ion? Well, it's got to be a 2 negative because we have 2 hydrogens. So this is the sulfate ion. So we're going to write sulfate, drop the AT ending. And again, remember, this is one of those weird ones. So it's not going to be sulfic. It's going to be sulfuric acid. And so here's the name of this acid. Now, I want to point out, look, these are similar. This is sulfuric acid. This is hydrosulfuric acid. So the fact that this has hydro means that this is a binary acid. This does not have hydro, so it's a oxy acid. So don't confuse these names. They look similar, but they refer to different acids. And so that's it for this video. I hope you enjoyed the video. I hope you learned about naming your acids. So hopefully you feel better about that. If you enjoyed this video, if this helped you in any way, please make sure you like the video, hit that like button, share the video with your friends, subscribe to my channel. Make sure you hit that notification bell and then click all for all my videos so you can be notified by any video I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me. Have a great day.